All right, so this video is about dividing polynomials. And we can write a division of polynomials like this, a fraction, or we can write it like this using a divide sign. They both mean the exact same thing. So today I'm going to do 3 of them for you. The first 2 are going to work out quite nicely, and then the last one will have a remainder, and I'll show you how that works as well. So let's just kind of go through the first one. So we're going to use kind of the basic idea of long division, which you learned back in, I don't know, a long time ago. But it uses the same idea where, we write it out as x plus 3, and then we use our divide sign, right? And inside we write what we're dividing. So x cubed minus 3x squared minus 16x plus 6. Now, the basic idea is to come up with each term, figure out what that term, how much of the polynomial that single term sort of accounts for, and then we use subtraction to figure out what we still have to work with. So the very first thing we say is, well, look, I need to get this x cubed. Here I have an x, so the only way to get an x cubed is for my solution to have an x squared, so that when I take the x squared and multiply it by the x, I get the x cubed. But in our multiplication that we did, we know that if I take x squared and multiply it by x plus 3, I need to distribute not only to the x, but also to the plus 3. And so that's why it's plus 3x squared. Now, at this point, this is sort of the tricky part, and this is definitely the part that most people get tripped up on. To figure out what's left over, we obviously have to use subtraction. Now, if I use subtraction, I gotta remember, all right, x cubed minus x cubed, that goes away. This should always go away. If this column doesn't go away, then you've made a mistake in your answer choice. But in any case, so this column goes away. So now we have to worry about this column. So they're both x squareds, which is important because I can only add and subtract the same type of term, which is an x squared. But notice, this is going to be a minus, this is a negative 3, minus 3. Well, a negative 3 minus 3 is a negative 6x squared. So be careful and be sure to distribute this negative here so that you remember negative 3 minus a positive 3, making it a negative 6x squared. This is by far the most common mistake right here, not distributing the subtraction correctly. But just like long division, we then just bring everything else down. So there's a 16x and a 6. And that's pretty much it. It's just that we just do this over and over again. So the next thing is I need to use this x and I need to somehow get a negative 6x squared. That's what's left over here. This is what's left over after we decide that this is in our solution. So how do I get this negative 6x squared from an x? Well, I'm going to need a negative 6x. Negative 6x times x. My negative 6 is there, and x times x is x squared. So this is a negative 6x squared. Perfect. So when I do that, I also get my negative 6x squared, but I also get a negative 18x from negative 6x times 3. At this point, remember, though, I am subtracting. That's extremely important. Negative 6x squared minus negative. So that means I'm adding, right? So negative 6x squared plus x squared, 6x squared is 0. So that was negative 16x minus negative. That means, again, I'm adding. Negative 16x plus 18x is a simple 2x, and then bring the 6 down. So then we need to get a 2x from an x. Well, that's simple. It's a 2. So 2 times x is 2x, and 2 times 3 is 6. When I subtract that, that's pretty easy. They match up exactly. That's 0. That means there's no remainder. And so my answer here is x squared minus 6x plus 2. There you go. So let's do another one. We got 2 more here. This one also works out pretty nicely. It's just a little bit longer, but it's actually, exactly the same. So 2x minus 1 and I'm going to divide negative 4x to the fourth plus 8x cubed minus 11x squared plus 14x minus 5. Okay, I need to get a negative 4x to the fourth from a 2. Well, that's going to be negative 2x cubed. That's going to give me my negative 4x to the fourth when I multiply it by 2x, and it's also going to give me a positive 2x cubed. Now I subtract. When I subtract, I'm going to get negative 4 minus negative 4, that goes away, and 8 minus 2. And then bring everything else down. All right, let's continue on. What am I going to have to do to 2x to get it to be a 6x cubed? Well, clearly from 2 to 6, I need to multiply that by a 3. But to get x to x cubed, I need an x squared. This gives me my 6x cubed and my minus 3x squared. Again, I need to subtract. When I subtract, this is negative 11 minus negative. Minus negative means I'm adding. Negative 11 plus 3 is negative 8x squared. (2x to negative 8x squared is going to be a negative 4x. That gives me my negative 8x squared. It also gives me my positive 4x. When I subtract, the negative 8x squared goes away, and now I get a positive 14x minus 4x. So 14 minus 4 is a 10x minus 5. That's great because my last thing here, what am I multiplying 2x by to get a 10? I'm going to have to do that by 5. And this works out perfectly, as I said. It was going to, right? So no remainder. So my solution here is negative 2x cubed plus 3x squared minus 4x plus 5. That's good. All right. Now this one is going to have a remainder, as I said. So I'm going to show you how to deal with that. All right, so exactly the same way, we're going to set it up. So we've got a 3x plus 4, and I am dividing a 3x cubed minus 8x squared minus x plus 23. All right, well, the 3's are the same, so this thing is going to have a coefficient of 1. But to get from x to x cubed, I need an x squared. So x squared times 3x is 3x cubed, and x squared times 4 is a positive 4x squared. Okay, now again, I am subtracting. That makes the 3x cubed go away, but this is a negative 8 minus 4. So if I do negative 8 minus 4, that actually gets me all the way up to a negative 12x squared minus x plus 23. All right, so what am I going to have to do to 3x to get it up to a negative 12? Well, that's going to need a negative 4. And this has 1x, this needs 2, so I need an extra 1, right? So negative 4x times 3x is negative 12x squared. Then I do negative 4x times 4, giving myself a negative 16x. All right? I'm subtracting. So when I subtract, negative 12 minus negative 12 goes away. But negative x minus negative, well, that's going to be plus. So negative x plus 16x, that's going to be a 15x plus 23. All right, last thing, 3x times 15x. Well, 3x to get to a 15x would mean I have to multiply by 5. That's going to give me my 15x, but it's also giving me a positive 20. So when I subtract, I'm left with a 3. So now I have a remainder here. So, depending on how I ask for it, sometimes you can just say the remainder is 3. Other times, they might want you to write it as a fraction. So the way we write it as a fraction is we say, well, this is going to be x squared minus 4x plus 5. But there is this 3. And this 3, I was never actually able to divide by 3x plus 4. It was just, it was there, and I can't divide it by, I cannot divide 3 by 3x plus 4 because this has an x and 3 obviously doesn't. So I write it as a remainder, and I say, oh, well, 3 was still around, and I never actually got to actually divide it. So I'm just going to write it as a fraction, or as a division. And so you can write your solution like that. So that's how you do long division for polynomials. Hope that helps out, and good luck on the next assignment. Have a good one.